Sorry, I took time. Yeah.
Thank you, Ganit, and congrats to your team. Next, we've got Doclingual. Mardiyyah, are you presenting?
Bella is.
Hi,
Hi,
I
Bella.
am presenting. So both me and Sriniketh will be presenting this presentation, but I'll start. So this is just so you get to know our team. Can you please go to the next line? Okay. So our core idea was to generate essentially a talk to your PDF application. But instead of doing what everybody else doing, we really wanted to focus on law documents. So that was our key application. And the reason we wanted to do is to have a greater impact. And it's not only something that we think ourselves, but the Sustainable Development Goals thinks too. It has a lot of focus on peace, justice, and strong institutions. And we believe our work can act as a tool, as an enabling technology, and to reduce language barriers. Next slide, please. So our idea was quite simple, to find a data set, which was law focused, build a retriever, and to keep our LLM frozen, just to act as an interface between our retriever model and our final user. Next, please. So to have this data set would work, we would need a data set that has both context and questions and answers, and we could not find such document or such data set. So we end up creating our own data set, and we chose to go with the Urlex dataset, which has over 65,000 laws, and they have the same laws in different languages. So that was one of the reasons we wanted to do it. We wanted to use this dataset, and we ended up choosing 5 languages, which were the languages that the people in our team could speak, because we first evaluated ourselves the questions that we were answering. And I ended up going with Command R because its results were better than all the other models, and they were very similar to Command R Plus. We couldn't ourselves distinguish between the two of them. We generated 2,500 questions for all the documents, and we can expand this in the future. And then to annotate the answers, that was quite tricky because then we would need to have a law background. So we also use LLM as a judge. We use 4 different LLM models, and then we actually were interested in if they were agreeing or disagreeing with each other, and we really saw them as annotators. Next slide, please. So on the dataset evaluation, we first asked the LLM models to rate 0 to 5, and you can see that the median ratings are quite good. But when you look at the Cohen kappa, which is our metric to see how much they agree, they don't agree that much. And you see that this pattern of real-linked and embedded agreeing with each other is quite strong compared to the others. One quick notice is that both Cohen and Twice kappa, they're not 0 to 1. They can be negative if they disagree a lot. And usually from 2 is already a fair good agreement because it also takes in consideration just your random expected agreement. So, next slide, please. We wanted to see if the entropy was distributed across the data set or just in questions that were poor. And it's actually kind of random. So it does not have a pattern, which means that the median rating is not a good correlation to that, which means we cannot see how much they are disagreeing with each other. So next slide, please. So to see if it was because of the 0 to 5 was not giving enough room for the models to evaluate, we redid this analysis, but going 0 to 10. Next slide, please. And we can see that although we have promising results when we look at the median ratings, the models start rating more 6s and 7s than before. But actually, when you look at the entropy, you can see that they still disagreeing on which data set is, which question is good and which question is bad. So next slide. And we can see that it also changes as expected because it has a greater number of categories, our agreement goes down, but it still holds true that we rank and embedded rate the questions very similarly, but now we switch from the mapping that we had before. So right now, Command R is closer to those than it was before. Next slide, please. So here is what we do if we can do all combinations possible. And we can see from the 0 to 5, we have a good agreement between re-rank and embedded, but we also have a good agreement between Command R plus re-rank and embedded. And on below, you can see that they just disagree everywhere if you ask them to rate 0 to 10. And it's mostly just re-rank and embedded that agree with each other. Next slide, please. So we know that the models are thinking our answers are good, but they disagree on which ones are not. And we know that so far it's not related to 0 to 5. We plan to evaluate this data set further to see if it's language-based or document-based, but we're not there yet. And I'm just going to pass to Srinik, who's going to spend like the next step of our pipeline, which is the retriever model.
Yeah. So, hi everyone. Sorry for not turning up the video on. I'm not in a good position, but still, let me just try to uh, keep my presentation as possible as good as I can. So yeah. Sort of the way how we build a retriever is we had a list of documents. So we are using the haystack pipeline. So it is something but a list of documents. And then I convert those documents to embeddings using embed multilingual V2 model of Cohere. And then I'm using another embedding of embed multilingual V2 to convert the query to embeddings. And then I'm using an cosine similarity between these both models using an in-memory retriever, which will perform a cosine similarity search, and then it'll be passing that model to the LLM. So next slide, please. Yes, so over here, after like we get the list of documents which are very closest, we'll be using a prompt engineering kind of a thing, and we'll be generating using command R model. The reason we are going for command R, it produces better results. That's the reason for choosing command R. So yeah, that's how we generate the response. Yes, the next slide. So overall workflow of how this pipeline works is available here. So you could see over here, it starts text embedder, then a retriever and a prompt builder, and then LLM. Yeah, the next slide. Yeah, so this is the model evaluation pipeline. So the next slide would summarize all these together. Yeah, I've used the retriever model evaluation over here with different metrics like faithfulness and aspect critic and answer relevancy. So the faithfulness and answer critic didn't prove great evaluation metrics because they can't handle multilingual data. With the help of answer relevancy, I was able to understand that our retriever model is almost able to get to the right answers, and the few which are in the lower case are especially on the languages which are not very much familiar, especially on the European and other languages. Yes. So the next slide.
Okay, so just to wrap it up, our plan is to extend our data set further to the 23 languages that we have remaining and further validate it in more complex metrics. And especially also see if it's documents or IDs or the metrics. And then we also want to benchmark our approach against others, and we want to improve our retriever on unseen data. After we have this pipeline, we want to use low resources languages to also test this on low resources languages and generate the data set for lower resources languages. And then we plan to restructure our code as a pipeline so people can use this out of the box. We also want to publish our data set when we have the complete version and write a paper. So thank you, everybody. That's all.